Yes. Then final paper to MCQ. Final paper to MCQ. And final paper to MCQ. Right. So then question number 1. Question number 1. Out of following units, the units of sound intensity is sound intensity unit is sound intensity. Sound intensity, not intensity level. Sound intensity means we all know that watt per meter squared. Watt per meter squared. Are there any unit like that? Sound intensity means we know that. We know sound intensity equation is I equals power of area. Power of area. Watts per square meter. W M W m to the power minus 2 watts per meter square. Then power measured in watts. If not, power is, we all know that. Power means what? Power means energy over time. Power means we all know energy over time. The units of power is watts. There is another units of power, that is what? Energy over time. Energy over time, energy measured in joules, time measured in seconds. Then the power of the units of power will be joules per second. Joules per second. Therefore, units of power is joules per second over the units of area. Area going to be meter squared. Then we can write down joules per second per square meter. So they have the right answer is fifth one. So they have the right answer going to be fifth one. Joules per second per meter squared. Answer is fifth one. Then number 2. Answer is fifth one. Question number 2. Which of the following is assumed in kinetic theory to explain the behavior of an ideal gas? Now we are doing many assumptions. Under kinetic gas theory we learned. So when we learn about gases, right, when the gas is ideal, and we are talking about many assumptions. Capital A statement: the intermolecular forces are negligibly small. The intermolecular forces are negligibly small. Statement now there are 3 statements. Statement is statement B, statement C. Statement C is correct. All the molecular move randomly with same speed. Wrong. Statement C is wrong. Okay. So if I go to statement A, B, and C, A is correct. Statement B, statement C. Statement C says that all the molecules move randomly. That's correct. With same speed. Wrong. Different directions, different speeds. All the molecules in that gas sample move in random directions with different velocities in different directions. Therefore, statement C is wrong. Statement C is wrong. Statement C is wrong. So then what we know then there are 2 answers. One is then statement C is wrong. Then we can remove that. We can remove option 4 and option 5. We can remove it. Then there are 3 options. Statement A says that the intermolecular forces are negligibly small. The intermolecular forces are negligibly small. Okay, that is also correct. Normally we consider intermolecular forces are negligibly small. That's correct. Statement B: the time taken for a molecular collision is negligible compared to the time difference between 2 collisions. The time taken for a molecular collision is negligible. Let's try to explain. The time taken for a molecular collision is negligible compared to the time difference between 2 collisions. Okay. Statement B also correct. So therefore A and B correct. The right answer is third one. A and B correct. Right answer is third one. A and B correct. Right answer is third one. Third one. Third one story. Right answer is third one. And question number 3. Question number 3. Next idea. Here they are asking. In this question they are asking. The angular velocity at which the Earth rotates around its own axis of rotation is. They are asking what is the angular velocity of the Earth which rotates around its own axis. We want to find the angular velocity of the Earth around its own axis. Angular velocity means omega. But we want to find angular velocity omega in radian per second, radian per hour, rad per hour. I want to find angular velocity omega in rad per hour. Yes. But we know when you consider the Earth, when the Earth completes one complete rotation around its own axis, when Earth completes one complete rotation around its own axis, the time taken, the time period, the time taken is 24 hours. 24 hours. Right? When the Earth completes one rotation, what is the angular displacement theta? 2 pi. If the Earth completes one rotation, the angular displacement, the theta going to be 2 pi. Theta going to be 2 pi. The time taken to complete one rotation is 24 hours. Then we know that angular velocity means angular displacement over time. You remember the equation omega equals theta over t. The equivalent equation is V equals displacement over time, S over T. Omega equals theta over T. Angular displacement when the Earth completes one rotation, theta is 2 pi. Time taken is 24 hours. Theta is 2 pi, time is 24 hours. So we can simplify it. Then pi over 12 is the answer. Are there any answer pi over 12? Then 2 pi radian. 2 pi radian. Time is 24 hours. The radian per hour. Pi over 12 radian per hour. Answer is second one. Pi over 12. Answer is second one. Answer is second one. Then question number 4, 5. Fourth one. There are two tubes. There are two tubes. First tube is one enclosed. Second one is two end opened. Otherwise, both of them are identical. There are two tubes. First tube is one enclosed. Second tube is both end open. Otherwise, both of them are identical. That means the length, the cross-sectional area of both the tubes are same. The only difference of them is one enclosed, other one is both and open. Right. When they vibrate in fundamental tone, which quantity is equal? Which quantity is equal? Now we'll draw the diagram, we'll try to understand. There are two tubes. Open tube, one enclosed tube, one an open tube. This is the closed end tube. This is going to be open end tube. Right. Shall we draw the wave pattern? Shall we draw the stationary wave? Now, if the air inside the closed tube and open tube vibrates under fundamental frequency, if I draw the stationary wave pattern, fundamental frequency, closed tube means stationary wave pattern. If it is both an open tube means stationary fundamental tone wave pattern. Then if it is closed tube, we know that how many nodes are there? There is one node, one antinote. There is one node, one antinote. One node. This is one antinote. If it is both an open tube, means there is one node. There is one node. How many antinodes are there? If the air vibrates under fundamental frequency in closed and open end, one node, there are two antinodes. There are two anti. Right. Now they have given some answers. They are telling when they vibrate in fundamental tone, which quantity is equal. We know that frequency different, right? Even these two, now same length, they are having same length. These two tubes have same length, right? Same length, same cross-section area. But remember, since one tube is one enclosed and other tube is both and open, their fundamental frequencies are different, right? Their fundamental frequencies different. Then I taught you, then wavelength also different. Fundamental frequency different, wavelength different. According to V equals F lambda equation, we know that if frequency different, wavelength different, but we know that speed of the wave, speed of the longitudinal wave, speed of the sound wave. Now these are longitudinal waves, right? So we know that when now some people have a misunderstanding. Now Now in the question also they are telling fundamental frequency of the closed end tube, fundamental frequency of the open end tube. But remember, basically they are fundamental frequencies of the air trapped inside the closed end tube, fundamental frequency of the air trapped inside the both and open tube. Right? What is the type of wave propagating through air? That is longitudinal wave. That means sound waves. Right? So then we know that speed of sound waves depends on mainly temperature. Now we want to assume both of them at same temperature. Therefore, remember, speed remains constant, frequency and wavelength changes. So therefore, we can tell that wavelength changes, speed same. I think the right answer is the second one. When they vibrate in fundamental tone, which quantity is equal? Definitely the speed. Frequency is different. Then 1 wrong, 3 wrong. Number of pressure knots. Displacement antinodes. Now remember, normally now here I have marked nodes and antinodes. Here I have marked nodes and antinodes. Remember, normally we consider nodes and antinodes as displacement. Normally we mark nodes and antinodes as the displacement nodes and displacement antinodes. Right? Normally, remember, if I mark this point is node, this point is antinode, this point is anti-node, means these are displacement nodes and displacement antinodes, right? But pressure node means, remember, pressure is max pressure. Okay, pressure node means pressure is minimum. According to the pressure story, this is going to be pressure node. Displacement maximum is pressure is minimum. Here, displacement node, but pressure antinode. Pressure is maximum. Right here, displacement is maximum, pressure is minimum. Therefore, at here, pressure node. Here, pressure node. Here, displacement is minimum, pressure is maximum, pressure antinode. So, when your answer is second one, just grab the stories. Second one, nice question. Answer fourth one is second one. Fourth one is second one. Then 5. Now tomorrow and day after tomorrow we'll do the classes. Theory class and passive discussions. Should give priority to finish electricity and electric field, because then we can do some good paper questions in these papers. But somehow we'll finish next month. I will work more. Now tomorrow onwards I'm working more. Don't worry. 5. Somehow want to finish the story. Fifth one. Right. Okay. Fifth one idea. Now, when a copper sphere is heated, the percentage changes. When a copper sphere is heated, the percentage changes. When a copper sphere is heated, the percentage changes. Can do. Now, okay. When a copper sphere is heated, percentage changes greater in radius, greater in volume, greater in density, equal in volume and density, greater in surface density. Okay, right. Look here. This story. Right. This story. I will discuss. I will come to this question. It can do. I will come to this question. Sixth one. The moment of inertia of an object can be changed by. Moment of inertia of an object can be changed by. 3 statements are there. Statement ABC. Statement ABC. The moment of inertia of an object can be changed by. Statement A, by changing the axis about which it rotates. That's correct, because you know, when you consider rod, if you consider a horizontal rod, we know that based on the axis of rotation, if you consider this axis which passes through the center of the rod, if you consider the axis passing through one of the ends of the rod, based on the axis of rotation, remember, moment of inertia changes. So therefore, remember, moment of inertia of an object can be changed by changing the axis about which it rotates. That's correct. If you change the axis, moment of inertia can be changed. Statement A is correct. Then statement B, by changing the way how mass is distributed around the axis, that's also correct, because we know moment of inertia depends on the mass distribution. Moment of inertia depends on the mass distribution. Statement B also correct. But remember, statement C is wrong. Statement C. By changing the angular velocity, there is no link with the angular velocity, right? Moment of inertia does not. Angular momentum depends on the angular velocity something. But remember, moment of inertia. Moment of inertia doesn't depend on the angular velocity, rotational speed. Moment of inertia means depends on mass, axis of rotation, mass distribution. So therefore statement C is wrong. Statement C is wrong. Question number 6. The sixth answer is I think only A, B and correct. Sixth one answer is only A, B and correct. Answer is second one. Answer is second one. Answer is second one. Then question number 7. The near point of a defective eyes of a person is 0.5 meter. The near point of a defective eye is 0.5 meter. 0.5 meter means 50 centimeter. 50 centimeter. The magnitude of the power of the lens. The magnitude of the power of the lens that he should use to bring the near point to 0.25 meters. Now, there is a person. That person's near point is 50 centimeter. And somehow we want to bring that person's near point to 25 centimeter. Then I told you that in these cases, we are using a convex lens. In these cases, if he has the issue with the near point, normally for a healthy near point is 25 centimeter. But this person's normal near point is 50 centimeter. It's a problem, right? So in that cases, we are using a convex lens. In that cases, we are using a convex lens. Convex lens, right? This is the eye. And we are using a convex lens. We are using a convex lens. What's our plan? But I don't know the focal length of this convex lens. I have no idea. The question they're asking magnitude of the power of the lens that he should use to bring the near point to 0.25 meters. The focal length is, I say, if focal length of the convex lens simple if. Power, then I can find power, I can find it. Doesn't matter. Focal length simple if. So then now what's our target? Now our target is this eye's near point is 50 centimeter. This eye's near point is 50 centimeter. If I mark 50 centimeter, somewhere here, this gap going to be 50 centimeter. This gap is 50 centimeter. And I mark the 25 centimeter location also. This point is 25 centimeter something. This point is going to be 20 centimeter. This gap is going to be 25 centimeter. 25. Right. What's our target? Now somehow we want to make this eye's near point as 25 centimeter. Actually, eye's near point is 50 centimeter. But we should somehow bring the near point to 25 centimeter. What does it mean? Bringing the near point to 25 centimeter is the meaning. The meaning is you should, if you keep the object at 25 centimeter, because when you keep normally, just forget about the convex lens from the naked eye. From the naked eye, when you keep that naked eye near point is 50 centimeter. If you keep an object at 25 centimeter, that person can't see that object clearly. But by using convex lens, what we are going to do is we are going to keep the object exactly. We are going to keep the object exactly at 25 centimeter. But we are going to show that object now. We are going to keep the object at 25 centimeter. But you can clearly see that object. So what's our target? By using a convex lens, we are keeping the object exactly at 25 centimeter, and we are going to create an image. We are going to create an image exactly at 50 centimeter. That's our target. For the convex lens, this is going to be the object. For the convex lens, this is going to be the image. It's the idea. Many times we learned. This story we learned many times. Many times. So what we can do, you want to do lens equation. So if you apply lens equation for the convex lens equation, 1 over v minus 1 over u equals 1 over f. In sign convention, 1 over v minus 1 over u must be equal to 1 over f. So then parallelly apply sign convention also. Since it's a convex lens, therefore sign convention. For a convex lens, it's a minus. Then actually light rays passing from object towards the convex lens. Direction of light rays right side. But you understand this object distance, image distance, they are opposite to direction of light. Therefore, u is plus, v also plus. Then substitution. My object is here, image is here. Then image distance is going to be 50 centimeter, 1 over 50. Image distance is going to be 50 centimeter, 1 over 50. 1 over 50 minus object distance is going to be 1 over 25 centimeter must be equal to minus 1 over f. Minus 1 over f. Minus 1 over f. Common denominator going to be 50. If f is the common denominator, then here it's 1 minus here it's 2 must be equal to, here 1 minus 2 must be equal to minus 1 over simple f. And then simply you are getting that, simply really simplified, your f is going to be equal to exactly what? So f is exactly going to be equal to 50 centimeter. Then we know we can find the power now. If the focal length of the convex lens is 50 centimeter, the power we can find simply. We can easily find the power. What should be the power? The power should be power equals 1 over f, right? Power equals 1 over f. Power equals 1 over f. You want to substitute the focal length in meters. 1 over 50 centimeter. You want to convert into meters. 1 over 50 10 to the power minus 2. Minus 2 goes numerator. 100 over 50 means exactly 2 diopters. Therefore, plus 2d. Plus 2d. Plus 2d. Plus 2d. So therefore, question number 7 answer is 2 diopters. Therefore, answer is first one. Question number 7 answer is first one. Answer is 1. Then question number 8. The gap between lens of an astronomical telescope at normal adjustment is 78 centimeter and the angular magnification is 12. The focal length of the eyepiece. We know the telescope at normal adjustment. I have explained this story many times. When you consider a telescope at normal adjustment, that story. Question number 7, question number 8. Remember, when you consider the telescope at normal adjustment, the gap between two lenses, objective lens and eyepiece lens. The gap between objective lens and eyepiece lens. This is objective lens. This is your eyepiece lens. Remember, if the telescope is at normal adjustment, the gap between objective lens and eyepiece lens is going to be equal to the addition of focal lengths of objective lens and eyepiece lens. The gap between them is going to be equal to f4 plus fe. And also angular magnification equation is, we know that when the telescope is at normal adjustment, angular magnification is going to be equal to f0 over fe. Learn by heart. Angular magnification is equal to f0 over fe. This story we learned. Then the near point of the defective eye, okay, then 78 centimeter. The gap between the lenses 78 centimeter. Angular magnification 12. The focal length of the eyepiece. So then see the idea. Capital M is 12. Capital M is 12. Must be equal to f0 over fe. I want to find the focal length of the eye. I want to find fe. If I subtract f0, my f0 is going to be what? 12 fe. And also we know that the gap between these two lenses is 78 centimeter. 78 centimeter. Then we can write down f0 plus fe. So we all know that f0 plus fe must be equal to what? Must be equal to 78 centimeter. 78. Then our f0 is 12 fe. f0 means we know it's 12 fe plus fe. Must be equal to 78. And 12 plus 1 means 13 fe. Subtract fe. Fe going to be 78 over 13. Fe going to be 78 over 13. Right, 12 plus 1 means 13 fe must be equal to 78. 78 over 13. They're asking what focal length of eyepiece is. Then 78 over 13. How much? Someone just divide the 78 by 13 and tell me what is the answer. Just divide 78 by 13 and tell me the answer. 65, 75, 76 centimeters. 13 into 5 means 65. 13 into 6 means 78, 6 centimeters. 6 centimeters. We are getting away here 6 centimeters. 6 centimeters of our answer. Our F is going to be 6 centimeters. Okay. 6 centimeter. Right? Clear? It's clear. So then this question answer is fifth one is the answer. Answer is 5. Answer is 5. Question number 9. Question number 9, we'll discuss 9 bit later. Then we'll go to question number 10. Sound one, okay. Now easy questions we'll do first. Then we'll go back to the difficult questions. Question number 10. 11. Metal cylinder is heated uniformly using heating coil of 12 watts. Very similar questions. Metal cylinder is heated uniformly using heating coil of 12 watts. It becomes steady. Now I have discussed same, maybe similar question last day paper also. A metal cylinder is heated uniformly using heating coil of 12 watts. It becomes steady at 45 degrees Celsius. If the environment temperature is 15 degrees Celsius, then the rate of heat loss to the environment at 20 degrees Celsius is rate of heat loss to the environment at 20 degrees Celsius. I have done very similar question in final paper 1 also. Question number 11. So we all know that if an object reaches steady state means, now initially this metal cylinder is heated uniformly using heating coil of 12 watts. Just think there's a heating coil. There's a heating coil inside the metal cylinder. There's a heating coil. So initially, this metal cylinder absorbs the heat from the heating coil and metal cylinder increases its temperature. Initially, the heat released by the metal coil going to absorb by the metal cylinder initially. So once its temperature, metal cylinder's temperature reaches, we know, 45 degrees Celsius. Then what happens? Metal cylinder reaches steady state. What does it mean by metal cylinder reaches steady state? When the metal cylinder obtains 45 degrees Celsius, till 45 degrees Celsius, metal cylinder absorbs all the heat produced by the heating coil. Once it's reached 45 degrees Celsius, now metal cylinder won't absorb the heat. But once metal cylinder reached 45 degrees Celsius, metal cylinder won't absorb the heat from the coil. But we know coil keep on continuously producing the heat. We know coil keeps on continuously producing the heat. Then what would happen for that heat? That heat dissipates. If the metal cylinder is not absorbing that heat, if the temperature is 45, then we know that heat gonna dissipate to the surrounding. The heat initially that heat gonna dissipate to the surrounding. Initially. This story we know, right? So then once its temperature reaches 45 degrees Celsius, metal cylinder won't absorb heat. Whatever the heat produced by the coil going to entirely dissipate the surrounding. So what is the rate of dissipation of heat from the metal cylinder? Same as 12 watts. The rate of heat dissipation. The rate of heat dissipation from the metal cylinder is to the surrounding is going to be 12 watts. Q dot going to be 12 watts. Right? Okay. This is some kind of convection story. Surrounding temperature is theta S. That is given as 15 degrees Celsius. Some kind of convection question. So we know that convection question, the equation is Q dot equals Ka excess temperature. In convection questions, the equations we know that Q dot equals Ka excess temperature. When is the equation? Q dot equals Ka excess temperature theta minus theta S. Right. Then we know K is a cooling constant. It depends on the material. Right. A means the total surface area of the cylinder. then what you can do, you can write down that actually is rate of heat dissipation proportional to excess temperature. If you say K and A are constants. In the beginning, we noticed that when the moment cylinder reaches 45 degrees Celsius, rate of heat dissipation for the cylinder is 12 watts. So therefore, we can write down 12 proportional to excess temperature 45 degrees Celsius minus 15. Temperature of the metal cylinder minus surrounding temperature 45 minus 15 is how much? It's going to be 30. Proportionality 1. In the question they are telling what? Question they are telling. The question they are saying that. Question they are saying. If the environment, okay, the rate of heat lost to the environment at 20 degrees Celsius. Now what you do? You are removing this coil. You are removing this coil when the temperature of the cylinder is 20 degrees Celsius. When the temperature of the cylinder is 20 degrees Celsius, what is the rate of heat dissipation from the metal cylinder? Same cylinder. Now you remove the coil. When you remove the coil, what will happen? Right? When you remove the coil, its temperature of the metal cylinder decreases from 45 to 40 to 35, 30, 25, 20. Now, at the moment, currently, at this instant, temperature of the metal cylinder is 20 degrees Celsius. When the temperature of because surrounding temperature is 15. Surrounding temperature is 15, but at this instant, temperature of the metal cylinder is 20 degrees Celsius. At this instant, you want to find the rate of heat dissipation. Because we know that, I explained that when the temperature of the metal cylinder decreases, we also know that rate of heat dissipation from the metal cylinder also decreases. So then you want to find now rate of heat dissipation. Let's say now it's lesser. Now rate of heat dissipation going to be lesser value. That is, let's say Q dot something, Q dot 1, no, Q dot 2, it's whatever. Q dot something, Q dot 1, no, whatever. Q dot 2 something, right? So then you can tell that now rate of heat dissipation from the metal cylinder is Q dot 2, follow this proportionality. Then Q dot 2 proportional to, and now excess temperature. Now excess temperature is how much? Now it's 20 minus, surrounding temperature doesn't change, same as 15. 20 minus 15 is going to be 5. So when you simplify these two proportionalities, Q dot 2 over, we simplify this, if you simplify this, then Q dot 2 going to be equal to, Q dot 2 over 12 must be equal to 5 over 30. Then I think it's 2 watts. How many of you say answer is 2 watts answer? It's 2 watts, because Q dot 2 over 12 must be equal to 5 over 31 over 6. Then 12 over 6 means 2 watts. It's correct. It's 2 watts. It's 2 watts. This question 2 watts. It's 2 watts. Then 2 watts. Answer is third one. Question number 11. Answer is third one. Then question number 12. A vessel with a small opening. A vessel with a small opening contains air at 6 degrees Celsius. To how much temperature should it be heated to remove 1/4 of the air in it? 1/4 of air in it. Question number 12. Question number 12. This story. Question number 12. There is a container, but it is open to the atmosphere. A vessel with a small opening. A vessel with a small opening. This container, this vessel is open to the surrounding. This vessel is open to surrounding. So then what is the conclusion? If the vessel is open to the surrounding, remember the pressure of the air inside the vessel is always equal to the atmospheric pressure. If the vessel is open to the surrounding, pressure of the air is always equal to the atmospheric pressure. The pressure is atmospheric pressure. I mark it as P naught. I mark it as P naught. Remember, since it is open to the atmosphere, since that vessel is open to the atmosphere, doesn't matter how much temperature that you are heating the vessel. Doesn't matter up to what temperature you are heating the vessel. Since the vessel is open to the atmosphere, remember, pressure of the air inside the vessel is a constant that is equal to the atmospheric pressure. That is the idea. Okay. So then, question: initial temperature 60. When you convert 60 degrees Celsius into kelvins, 273 plus 60 means 273 plus 60 means 333 kelvins. Now you want to find what they're asking, to how much temperature should it be heated? To how much temperature should it be heated? To remove 1/4 of the air in it. Let's say now, you remember, now you all know that the story is, remember, mass is proportional to gas moles. Gas mole proportional to gas molecules. Keep this story in your mind. The gas moles is proportional to gas molecules proportional to mass. This idea, This idea, just remember it. Remember this idea. Remember this idea. Then, shall we apply ideal gas equation? Now, with what the story is, there is a vessel, gas inside the vessel. That vessel is open to atmosphere. Then pressure is same. Doesn't matter you are heating the vessel or not. What's happening when you heat the vessel, when you heat the gas? What will happen is the gas will leave from the vessel. The gas will what? Goes out. When the gas goes out, the amount of gas mass inside the vessel decreases. When the gas is going out, the amount of gas mass in the vessel decreases. The amount of gas moles in the vessel decreases. The amount of gas molecules in the vessel decreases. Ideal gas equation, we all know that PV equals nRT. Ideal gas equation, PV equals nRT, arguing, right? Now they mentioned to remove 1/4 of the air in it. That means initially, let's say, when you consider number of gas moles, simply they mentioned that how much temperature should it be heated to remove 1/4 of the air in it. Initially, there was simple in number of gas moles to remove 1/4 of the gas. Now you are removing 1/4 of initial gas. What is the amount of mole you removed from the gas? You removed from the container. What is the amount of gas moles that you removed from the container? 1/4 of the initial amount. So you removed n/4 moles from the initial quantity. Then what is the remaining gas moles in the container, the vessel? 3 simple n/4 is the idea. People confuse the story. Amount of gas moles removed from the container is n/4. The remaining gas moles in the container is 3n/4. That is the important story. Then for the story, volume is constant for both them. Pressure is same for both the stories, and R constant. Then you can tell temperature is inversely proportional to 1 over simple. That's it. See, pressure is same. P naught, P naught. Volume is container volume, container volume. Volume of the gas is container volume, container volume. Then the R is constant. Then you can tell if it's subject T. T is proportional to 1 over N. Then this one, if you apply temperature going to be 333 proportional to 1 over N means 1 over simple N, proportionality 1. When you apply this proportionality for this scenario, temperature theta, that's what I want to find. Temperature theta, that's what I want to find. Theta proportional to a number of moles in the container. That is how much? 3n/4. 1 over 3n/4 means into 4. Proportionally 2. A division. Proportionally 2 over proportionally 1. Then we can write down theta over 333. We can write down theta over 333. Theta over 333 must be equal to 4 over 3 something. 4 over 3. 4 over 3 if you simplify it. Then here we are getting 111. Your theta going to be 444 kelvins. Your theta going to be 444 kelvins. But I think in this question, no right answer. As my understanding, this question, there is no right answer. It to remove 1/4 of air in it. to remove 1/4 of air. We are removing 1/4 of air. The remaining air inside the tank is 3NO4. We are correct. 444 kelvins. It should be 444 kelvins. But if you see, okay, if you subtract, if you want to convert to Celsius, right now they have given answers in Celsius. So you should subtract 273 from 444 kelvins. So then when you subtract 273, 444 Kelvin, if you want to convert to Celsius, subtract 273. Then here 1, here it's going to be 7 and 1. 171? Yes, the answer. 171 Celsius. 171 Celsius. Right. Therefore, right answer is third one. Right answer, third one. Right answer, third one. Right answer, third one. Right answer, third one. Question number 12, answer is third one. Okay. Next story. The next story. Then next story. Thirteen. Two satellites A and B rotates around the Earth in a circular path, and the radii of their orbits are equal. The two satellites A and B rotate around the Earth in circular paths, and the radii of their orbits are equal. The mass of the satellite of A is 16 times as that of B. The ratio between the period of rotation of satellite B and the period of rotation of satellite A. Okay, this story. This story, question number 13. 13. Look here. The 13th story. Question number 13. What you can do now? Question number 13. 13. Satellite rotates in a circular motion around the Earth. This is my Earth. Simply, this is my satellite. Moving in a circular motion. Moving in a circular motion around Earth. Moving in a circular motion around the Earth. Let's say mass of the satellite is simple lim. Mass of the Earth is capital lim. Simple lim, capital lim. Simple lim, capital lim. When the satellite moves in a circular motion, there is a centripetal force, that is the gravitational attraction force. Right? G, capital M, simple M, over R squared story, we know. So what you can do for the circular radius, distance measured from center of the Earth to the satellite is simple R. Angular velocity is omega. Angular velocity is omega. Likewise, you can define the variables. So what we do usually, we apply F equals m of the satellite. Considering the circular motion of the satellite, you want to apply F equals m of the satellite. If you apply F equals m of the satellite, what is the centripetal force? The gravitational attraction force. That is going to be equal to G capital M simple M R square. We all know the gravitational attraction force, we know. G capital M simple M over R square must be equal to mass of satellite is simple M. Centripetal acceleration is V squared over R omega squared. They are talking about time period. Time period means R omega squared. Omega squared. Omega means we all know that time period is 2 pi omega. Time period equals we all know 2 pi omega. Omega means we all know that 2 pi over T. Centripetal acceleration means R omega squared. Omega means 2 pi over T. So therefore 2 pi over T squared. That means 4 pi squared over capital T squared. That's it. So I have reduced the steps. Simple M cancel out. Then finally, remember, see this equation. The question what they are asking. The question they are asking, very simple story. In the question they are asking, now they mentioned there are two satellites A and B rotating in a there are two satellites A and B moving in a circular motion around the Earth. Moving in a circular motion around Earth. They mentioned the radius. The radius of satellite A and the radius, that means the circular radius of satellite A's orbit and the radius of the satellite B's orbit are same radius. R is same. Mass are different, but they mentioned mass of satellite A and mass of satellite B, they are different. but the distance r is same for both of them. See, r same. You know, mass of satellite cancel out. Capital M means mass of the Earth. G is a constant. When you consider Earth and satellite A, or when you consider Earth and satellite B, capital M is same, G is same, R is same, then pi square is definitely same. Then remember, time period does not depend on the mass. So therefore, you can tell from this equation we can tell that when you consider Earth and satellite A, or when you consider Earth and satellite B, remember G, capital M, R, pi all are same. Then you want to remember both satellites time period also same. Both satellites same radius means same time period. Why? Even though mass is different, since mass and satellite cancel out, mass does not depend for the time period, right? So therefore, 1 to 1 ratio. Fifth one is the answer. Third answer is 5. Third answer is 5. Third answer is 5. Next story. 13 done. Then I think one question number 18. We question number 18. I am giving all. Okay. 14. 14. Okay. 21 is easy. 21 is very easy. 21. Now question number 21. Just see. 21 means very simple. A space vehicle of mass capital M moving freely in a space with velocity v. Space vehicle mass capital M moving freely with velocity capital V. Mass capital M, velocity v. Just before the collision. Separates into two pieces due to an explosion. Just before the explosion, it separates into two pieces due to an explosion. If a piece of mass simple M remains stationary, if a piece of mass simple M remains stationary, the velocity of the other piece would be just after the explosion. It separates into two pieces due to an explosion. If piece of mass simple remains stationary, now it breaks into two. Let's say one piece remains stationary. This piece mass is simple limb. This piece mass is simple limb. It remains stationary. Just after the explosion, this one's velocity is 0. Right? This one's velocity is 0. And there is another piece. What should be the mass of that piece? Mass of that piece should be this piece mass should be how much? Capital M minus simple limb. This piece mass should be capital M minus simple limb. This one's mass is entire mass is capital M. This piece mass simple M means this one's mass is capital M minus simple M. They're asking us to find the velocity of this piece. Let's say this one's velocity is, let's say, v dash something, v dash. In the right side direction, we can apply conservation of linear momentum. Right side direction, you can apply conservation of linear momentum. Right side direction, apply conservation of linear momentum. Right side direction, apply conservation of linear momentum. Right? The velocity of the other piece would be right side direction, conservation of linear momentum. Right side direction, conservation of linear momentum. Total linear momentum of the system before the collision, before the explosion is capital M into V must be equal to total linear momentum of the system after the explosion. Since this piece velocity is 0, the linear momentum of this piece is 0, but this piece linear momentum will be capital M minus simple M into V dash. So if you substitute V dash, you get the answer. Your V dash going to be, your V dash going to be capital MV over, your V dash going to be capital MV over capital MB over capital M minus simple M. The right answer, capital MB over capital M minus simple M. Therefore, answer is third one. 21 answer is third one. 21 answer is third one. And just temporarily mark that question number 18 all. Somewhere else marked on question number 18, I am giving all. But if I have time, I will discuss question number 18 also. I think we can do the question. Question number 18 just temporarily marked on all. Because no answers. Temporarily question number 18 all. Temporarily question number 18 all. all. Right. Then we'll go to 21, 22, sorry, 20. A motor vehicle takes a bend of radius capital R with the maximum speed of 36 kilometers per hour. Stories we learn circular motion. Motor vehicle takes a bend of radius capital R with the maximum speed of 36 kilometers per hour. The coefficient of friction between the wheels, the coefficient of friction uh, between the wheels of the vehicle and the road is 0.8. For what value of capital R? For what value of capital R is the car likely to slide from the bend? 20. Question number 20. Question number 20. Car is taking a bend. Car is taking a bend. I do the side view. The road is the car. Thing like that. The road, the car. Center is so, the radius simple R. Then you know, I'm not explaining in deeper. Then you know that is the radius. Then the center, if the car is moving in a circular motion, there must be a centripetal force. That centripetal force is going to be the friction force. Friction force, the maximum friction force. You know that the maximum. Asking the maximum radius something means is the maximum friction force. That is going to be the static friction force. If max means F is something, that means mu r. Right, mass is simple name. Okay. So then what we do normally, circular motions, we apply F equals ME. Circular motion stories, we apply F equals ME. Centripetal force is going to be the maximum friction force. Centripetal force is going to be the maximum friction force. Centripetal force is going to be the maximum friction force. That maximum friction force is going to be what? Mu R. Mu R, you know that when you consider vertical equilibrium, mg must be equal to r. That stories I am not explaining. Then mu mg must be equal to simple limb. Then centripetal acceleration. Centripetal acceleration, we can say that v squared over r, if not r omega squared. Better view now, since they have given the velocity. Better to consider centripetal acceleration as v squared over r. V squared over r. Then v squared over r. Centripetal acceleration is v squared over r. Finally, simple m cancel out. Then what they ask in the question? In the question, they are asking for what value of r radius r. I want to find capital R. Subject R. With subject R, finally. With subject R, you are going to be v squared over mu g. V squared over mu g. Subject capital R, v squared over mu g. What is the v value? Your v value going to be 36 kilometers per hour. How do you convert to meters per second? If you want to convert kilometers per hour into meters per second, multiply by 5 over 18. If you convert 36 kilometers per hour into meters per second, 36 into 5 over 18, that means 10 ms minus 1. Convert 36 kilometers per hour into meters per second, that is 10 ms minus 1, 10 square. 10 square means 100. The mu value is going to be 0.8 g is 10. 100 over 100 over what this one is 100 over 8. 100 over 8 is how much? 100 over 8. For what value? If I'm wrong, tell me. 100 over 8 is how much? 100 over 8 is how much? 100 over 8 is how much? 100 over 8 means 100 over 8 means how much? 5 over, sorry, 50 over 4, 25 over 2, it's 12.5 something. 12.5 something, but there is a closer answer. 12.5 closer answer is 12. 12.5 meter is there. The closer answer is 12. The closer answer is 12. So therefore, we can take the 12 as the answer. We can take 12 as the answer. We can take 12 as the answer. Fifth one is the answer. Then 22. Question number 22. 22, what they're asking. Story. Velocity v of a particle is given in terms of time by the equation v equals something. V equals. They have given the equation v equals simply plus bt squared over t plus c plus bt squared over t plus c. V means velocity. Simple t means time. The dimensions of a, b, and c are. The dimensions of a, b, and c are. So then we know that see here. How many terms are there? There are three terms. Term 1, term 2, term 3. Then we can directly say that dimensions of a going to be equal to dimensions of velocity, that is LT minus 1. Dimensions of a exactly equal to the dimensions of velocity, that is going to be LT minus 1. Okay, right. Now see, t plus c. If you can add two variables means, if you are adding two variables means, these two variables should have same dimension. Then what can you say about the dimensions of c equal to times dimension, that is capital T. Remember, dimensions of c must be the dimensions of time, capital T. So dimensions of c going to be capital T. Only if I can find the b's dimension, problem solved. See the term. Now just think you are denominator as the time t, bt squared over t something. It's like bt. It's like bt. Now we know that see, when you consider entire term, bt squared over t plus c. T plus c means time. You can think you are denominator as a time. bt squared over t. That means bt. Remember, bt's dimension is equal to the velocity dimensions. Am I correct? So dimensions of b into t means time dimension. B into capital T must be equal to velocity dimension LT minus 1. Then you understand that simple b going to be, dimensions of simple b going to be LT minus 2. Tell me what is the right answer. Tell me what should be the right answer. What should be the right answer? Tell me what should be the right answer. Someone tell me. Please just go and check and tell me the right answer. Go and check and tell me the right answer. Go and check and someone will be the right answer. Answer is 5. Answer is 5. Now, so far, how many questions discussed? Tell me someone. How many we discussed so far? How many questions that we have done? 50 MCQs are there so far. How many questions we have discussed? Done. Around 14. Around 14. Right. Right. Okay. So then, okay. Right. Okay. So then, okay. We'll discuss question number 25. 25. An ideal gas at pressure capital P and temperature capital T has capital in molecules per unit volume. Capital in molecules per unit volume. if the pressure of the gas is changed to 0.5 p, temperature is changed to 2T, the number of molecules per unit volume becomes number of molecules per unit volume. So what we can do that case, you can consider the volume as unit volume. You can consider volume as 1 meter cube. Then you can solve this answer easily. Then you can solve this question easily. Question number 25. There are different approaches. 25. Question number 25. 25 story. What they're asking. Then that's the unit volume. We'll consider unit volume. Unit volume as 1 meter cube. Unit volume is 1 meter cube. Ideal gas at pressure P. Volume is 1 meter cube. Think like the unit volume 1 meter cube. Pressure is capital P, temperature capital T, then the number of molecules capital N. If the pressure of the gas is changed to 0.5 P, if the pressure of the gas is changed to 0.5 P, same volume, unit volume 1 meter cube, pressure is 0.5 P, and temperature going to be 2 capital T, then you want to find the number of molecules in dash. Number of molecules in dash is our target. You want to find in dash. Ideal gas equation P equals nRT. P equals nRT. Try to involve number of molecules capital N. Ideal gas equation P equals nRT. PV equals N capital RT. Simple N means we know that simple M over, right? Simple N means we all know that capital N over Avogadro constant. RT over RT PV. So same volume, 1 meter cube, unit volume, same, volume same. So you want to find N dash, right? Volume same, we know volume same. L is same, R is same, volume same. Then what you can do, you can see PNT, PNT. So what you can do, you can tell that capital N is proportional to, you can write down capital N is proportional to, if you will see this side, pressure over temperature. That's it. The initial number of molecules, capital N, pressure is P, temperature T. Then you can tell that in the beginning, when you consider unit volume, number of molecule proportional to pressure over temperature. Right, in this case, number of molecules that is N dash, number of molecules that is N dash, number of molecules that is N dash. Proportional to pressure is how much? That is 0.5 P. Pressure is 0.5 P over temperature, that is 2 capital T. Proportional to. We simplify 2 by 1. Simplify 2 by 1. N dash over N. N dash over N must be equal to. N dash over N must be equal to. Somehow you are getting here 0.25 capital N. Somehow you are getting your N dash as 0.25 capital N. 0.25 capital N, answer is 1. The number of molecules per unit volume becomes 0.25 capital N. So therefore, answer is first one. Question number 25, answer is first one. 25 answer is first one. Then next story. 27. Two identical organ pipes produce fundamental notes of frequency 200 hertz at 70 degrees Celsius. If the temperature of one of the pipe is raised to 27 degrees Celsius, the number of beats heard per second. The number of beats heard per second will be nearly. Okay. Right, that story. Right. Two identical organ pipes. Look here. Look here. Question number 27. We'll do it. Question number 27. When you consider organ pipes, normally it's organ pipes are open end pipes, right? Both end open. If you consider organ pipes, we all know that speed of the sound wave. We know speed of the sound wave is proportional to what V equals gamma RT over capital M. So we all know the speed of sound waves equal to gamma RT over capital M whole root. From this we know that speed of the sound waves proportional to the temperature. Correct me? Speed of sound waves proportional to the temperature. The story is okay. Sorry, speed of sound waves proportional to the root absolute temperature. Speed of the sound wave equation is gamma RT over capital M whole root. Then speed of the sound wave V is proportional to the root absolute temperature. The story I think you understand. The story you understand. Then next story. Next story is remember frequency. We know from V equals F lambda equation. See, when you consider V equals F lambda equation, listen carefully. If you consider V equals F lambda equation, since you are using same identical organ tubes, and both of them vibrate under fundamental frequency. Remember, when you increase the temperature, speed changes. When you increase the temperature, speed of the sound wave in the air changes. As a result, you want to understand frequency changes. But remember, wavelength remains constant. In this scenario, when speed changes, frequency changes. So therefore, you can tell, because we know when you consider speed and frequency, they are showing kind of direct relationship between speed and frequency. So therefore, frequency is proportional to speed. Hands up who understand frequency is proportional to then root absolute temperature. Hands up. Raise your hand, somebody if you understand. Then the frequency is proportional to root absolute temperature. Hands up. Frequency is proportional to root absolute temperature. Hands up. Remember, frequency is proportional to root absolute temperature. Okay, this story now I'm simplifying and I'm doing. Speed is proportional. Hands, the story is clear. Hands, just raise your hands. Speed of now. This is open end tube. When you consider open end tubes, there are two open end tubes. Listen carefully. There are two open end tubes. So they move under fundamental frequency. Okay. Right. Read the question. Read the question properly. Now initially, both of them were at temperature 7 degrees Celsius. Both of them are at the temperature 70 degrees Celsius. Then their frequency. Now both of them vibrate under fundamental frequency. There are two identical organ tubes. Initially, both of them were at same temperature. Then both of them vibrate under same fundamental frequency. That is how much? 200 hertz. Right? Fundamental frequency is 200 hertz. Now what happens now? I consider I'm going to increase the temperature of one of the organ tubes by maintaining this one at 7 degrees Celsius. If I increase the temperature of this organ tube to 27 degrees Celsius, we all know that when temperature increases, speed of the air propagating in the speed of the air propagating, sorry, speed of the sound propagating in the air increases. As a result, the fundamental frequency increases. Now, at 27 degrees Celsius, remember, the air inside the tube is not vibrating under 200 hertz. Now, fundamental frequency of this tube is larger than 200. That is, I don't know. Let's take it as F dash or something. Let's take it as F2 something. Right. I think up to now everything is clear. I hope, right? Hands up. The story is clear. Hands up. Raise your hands. How many of you understood what I explained? Hands up. The story is clear. Hands up. The story is clear. Hands up. Only 1, 2, 3. All of you understand? All of you can understand. The story is clear. The important thing is the most of you will struggle to get this one. Getting this one only, you will struggle. Right, but I quickly took it. If not, I can write the equation and I can get it, but I didn't do it. I quickly took it. Just think how this came. If you understood that, that's it. If you understood how that came, that's it. Okay, thereafter is C. Thereafter is C. So therefore, what you can tell, you can read that frequency is proportional to root absolute temperature. See what I am doing hereafter. Then see what I am doing. So therefore, you can say that this frequency is proportional to absolute temperature root. Okay. So then you can say that, sir, when the temperature is 70 degrees Celsius, the fundamental frequency of the open tube is 200. So 200 proportional to the 7 degrees Celsius in Kelvins. 273 plus 17 means 280, 290 root over. So now temperature of this tube is raised to 27 degrees Celsius. Then the frequency, I have no idea. I put it as F2. If you can find F2, that's it. This is F2. Then proportionality 1, proportionality 2. This is proportionality 1. This is going to be proportionality 2. This is proportionality 2. So when you divide proportionality 2 by 1, we are getting that F2 over 200. F2 over 200. F2 over 200 must be equal to how much? F2 over 200 must be equal to, if you divide it, root 300 over root 290, then 0 cancel out. Root 30 over root 29. Am I correct? Root 30 over root 29. If you simplify it, F2 over 200 must be equal to root 30 over root 29. Root 30 over 29, that is given as root 30 over 29 given as 1.02. So this value is given as in the questions. Look at the question. It is given as 1.02 into 200. Finally, I think we are very close to the answer. Then 1.02 into 200 means 204 hertz. Then we can find the beat frequency. Finally, I found that frequency of this tube. Fundamental frequency of this tube is 204 hertz. This tube fundamental frequency is 200 hertz. And the beat frequency is going to be 4 hertz. Answer is 4 hertz. Beat frequency, normally FB. Symbol is FB. FB going to be 4 hertz. FB going to be 4 hertz. Beat frequency is 4 hertz. Done. What is the answer then? Question number 27, 4 hertz. Answer is fourth one. Answer is fourth one. Answer is fourth one. Okay. Answer is fourth one. Right. So then 27 discussed. Now 29 seemed like a difficult question, but it's a very easy question. 29. 29, they are telling a big story. But I think at the end, the answer is very simple. Atmospheric air at 30 degrees Celsius. Now read the question carefully. When the question, if the question is asking from relative humidity, there are some stories. Atmospheric air at 30 degrees Celsius and having 70% relative humidity is made to flow slowly through 3 large chambers. Atmospheric air at 30 degrees Celsius having 70% relative humidity is made to flow slowly through 3 large chambers X, Y, Z maintained at 28 degrees Celsius, 24 degrees Celsius and 30 degrees Celsius respectively as shown in the figure. There are 3 chambers X, Y and Z. So we maintain each chamber at different temperature. Chamber X is maintained at 20 degrees Celsius. Chamber Y is maintained at 24 degrees Celsius. Chamber Z maintained at 30 degrees Celsius. Right. Densities of saturated water vapor at atmosphere at 24 degrees Celsius, 28 degrees Celsius. 30 degrees Celsius are 21.51, 26.93, 30.01 respectively. The relative humidity of the air, leaving the chamber is it will be. What is the answer? Now you know that sometimes they are really confusing us. The question, they are really confusing us. But if you properly think that, see, in the beginning, before air goes into the chambers, before air goes into chambers, before air enters to the chamber X, shall we tell the properties of that air? Temperature of that air was 30 degrees Celsius. Relative humidity RH was how much? 70%. Before that air enters to chamber X, temperature of the air was 30 degrees Celsius. Relative humidity was 70%. Now remember, relative humidity means remember, relative humidity means remember, relative humidity means remember, relative humidity means remember, rho over. Now we can go different stories. The equation for RH, relative humidity means current pressure. RH means remember, current pressure over saturated water vapor pressure at that temperature into 100%. Current pressure of the current water vapor pressure in that air sample over, if that air sample is saturated, then the saturated water vapor pressure at that temperature into 100%, right? Okay. So then RS changes when PO changes. That's the obvious idea. R changes when PO changes. Am I correct? Now initially AR is at atmosphere. AR before AR enter into chamber X, air was at atmospheric conditions. Temperature of the air was 30 degrees Celsius. Then the saturated water vapor pressure means rho naught 30. Pressure of the air going to be atmospheric pressure. Pressure of the air going to be atmospheric pressure. Okay. Now see, when the air is at chamber Z, when the air is at chamber Z temperature also 30 degrees Celsius. Then when the air reaches chamber Z, what can you say about the saturated water vapor pressure of the air at chamber Z? Same as P naught 30, same as before. It's leaving atmospheric pressure. So therefore remember RH, they're asking relative humidity. RH of the air leaving the chamber Z will be, they are not changing, same as before. Hands up, how many of you understood this question is not, hands up who understand the story, RH same as 70, hands up. Hands up, how many of you agree, understand, RH same as 70. 70 don't need to do this question, but I know that sometimes even I also sometimes confuse. That's obvious. Normally RH question is a bit confusing only. But don't think that story. So anyhow, you want to finish this paper also today, and okay, discussing full papers is not easy. It's not easy. Now I taught this 35. I taught you. I asked. Look here. I told the story. Right. Okay. Right. Right. Okay. 35 story. Okay, we'll come to 35. 38 is easy. 38 is very easy. 38 is very easy. 38 is very easy. What is the answer 38? 38 is very simple question. Somehow this week I will put classes. Monday I can't put. Then Tuesday I'll put. Tomorrow and day after tomorrow electric field. And Tuesday also electric field theory. Somehow Gaussian finished and we'll go to capacitor storage also. Don't worry. Then somehow we'll start electricity also and we'll finish electricity also. Parallelly we'll finish these properties of material story also. So then we can put questions in the papers also and we can discuss those stories also. I might do some extra classes. Don't worry. A liquid is in vessel shape as shown in the diagram. The liquid pressure at point A, B, C in the same horizontal level are P, A, P, B, P, C respectively. The correct relationship among these is, now we all know that when you consider point capital A, point capital B, point capital C, they are at the stationary. They are the stationary liquid, the same level. So then what can you say about the pressure? Their pressure must be same. PA must be equal to PB must be equal to PC. Therefore, question number 38, answer is 5. At higher statics, we learn that golden rule. If the liquid is stationary, if the liquid particles at same level, same liquid means they have same pressure. 39 also AC. 39 also AC. 39. Question number 39. 39 is AC. 39 is very easy. That in an adiabatic process, the relationship between pressure and density. Pressure and density ni, we wrote volume ni. We wrote volume. Therefore, I will come to that story also a bit later. PV gamma ni. Gamma means. Shall we do it? Shall I do it? Okay, we'll do it. We'll do it. Okay. Okay. 39. Can you remember what is the equation that we learned for adiabatic process? The equation P into V to the power gamma. Adiabatic process means delta Q is 0. Then pressure into volume to the power gamma is a constant. This is what we have learned. Am I correct? If I'm wrong, tell me. Pressure into volume to the power gamma is a constant. Hands up, how many of you agree with me? Pressure into volume to the power gamma is a constant. Hands up. This story. This story is okay. This story is okay. Ni? Now okay. Now we know for that given gas sample. For that given gas sample, we know that mass of the gas sample is a constant. Simple lim. For this given gas sample, mass is same as simple lim. When you change the volume, basically what's happening? Density only varying. Because mass can't change for a given gas sample. Mass is a constant. When you change the volume, basically density is changing. Then what you can do, you can write down P into volume means you can write down volume mass. Volume means what? We all know that mass over volume is density. We all know that this is story. Mass over volume is density. So then we know that if you substitute the volume means mass over density. Volume means mass over density. The power is gamma is a constant K. Then what you can do? See, expand the bracket. Pressure into mass to the power gamma over density to the power gamma is a constant. So then I can say that pressure over density to the power gamma, pressure over density to the power gamma, K is a constant over mass to the power gamma. So that's it now. K over, now mass is a constant. K is a constant. Then mass to the power gamma is a constant. This entire term is again a constant. K dash. K over m to the power gamma is a constant. Mass is a constant means K over m to the power gamma is a constant. Again, I can write down P over density to the power gamma is a constant K dash. So then you can keep like this. If you bring this one to the numerator, you can write down pressure into density to the power minus gamma is a constant. Any answer like this? Any answer? Any answer? Any answer? Correct me. Second one. Is the second one answer? Is it second one answer? It's second one answer. Second one. Second one. Third and second one. Third 9 is second one. The third 9 is second one. 9:34. We started at 7. Sorry, we start 8 o'clock. Second one. How many finished so far? Have you reached 25? No. Have you reached 25? No. Still not 25? How many so far? 19. So we have discussed 19, 21. 21 is, that is 49th one is easy. Question number 49 is very easy. 49 is very easy. Look at 49. If you go to the 49, Question number 49. It's very easy, right? Air inside one enclosed tube. Air inside one enclosed tube resonates at first overtone. Resonates at first overtone. Do the first overtone. If you do the first overtone. First overtone means closed tube, one enclosed tube. First overtone is look like this. Correct? Okay. Here, note, anti, anti. Which of the figure correctly shows the direction of the magnitude of the direction and magnitude of the air particles velocities? So we can obviously we know that air particles are vibrating this direction. Air particles don't vibrate up and down. So if we can eliminate option 1, option 3, we can eliminate. So remember at the nodes air particles can't remember air particles can't vibrate. Actually at the nodes air particles are stationary. At the nodes air particles are stationary. At the antinodes only air particles can vibrate with maximum displacement. Again at the node air particles are stationary. At the antnode only air particles can vibrate with maximum displacement. This is satisfying which question? Which answer? I think answer is fourth one. Answer is fourth one, 49, fourth one. 20 questions discussed. 20 questions discussed so far. 5 to go for the break. 5 to go for the break. Right. Right. Okay. Right. Okay. A thigh bone of a man is 32. Question number 32. 32. The thigh bone of a man is 45 centimeter long, has area of cross section this much. If its maximum compressive strain 0.002, maximum load it can hold safely. Maximum load it can hold safely will be Young's modulus. We know the equation F over A, Young's modulus E over L. F over A, Young's modulus Y, E over L. Right, this is the equation. E over L. Story. Story C. Story is very simple. Right. If it's maximum compressive strain, maximum load. Look here now, they have given EOL value. Maximum compressive strain. Stress strain. Now they have given EOL 0.002. Right? And they have given the cross-sectional area. And they have given the Young's modulus. I want to find the F. Very simple. Subjective. Then my F will be maximum compressive load means maximum compressive force. Maximum load means maximum force. I want to find F. The area, the cross-sectional area of the thigh bone is cross-sectional area of the thigh bone is 6 into, it should be 10 to the power minus 4 as per my understanding. It can't be 4. 6 into 10 to the power minus 4, I think, right? There's a small issue. Young's model is going to be 10 to the power 10. Strain is how much? Strain means EOL. This is what we call a strain epsilon. That is given as how much? 0.002. 0.002. If you simplify, you get the answer. Simplify, you get the answer. The maximum load will be how much? Here. Right here. 6 into 0.002 means 2 into 10 to the power minus 3, 10 to the power minus 4, 10 to the power 10. What is the answer then? 6 into, nobody answer 6. Nobody answer 6. So 12. So answer going to be, look here, the answer going to be, the answer going to be, the answer going to be 12 here minus 7, 10 means 1.2 into 10 to the power 4 newtons. Okay, done. 21 finished. 4 questions to go for the break. 4 questions for the break. Then next what? Next story. Next story, 33. 33. Gravitational potential energy at the point capital B, which is at the height of 3 capital R from the surface of the Earth with radius capital R is minus 16 over 3 kilojoule. What the minimum energy is needed to move the object from A to B? That story very simple. Look here. Look here. Look at this idea. Look at this idea. Earth radius R. This one 3 capital R. This Earth radius capital R. See, this is capital R. This is 3 capital R. They have given the gravitational potential energy at this point. I said W2. W2 given us how much? Minus 16 over 3 kilojoules. W2 is how much? Minus 16 over 3 kilojoules. Shall we find the gravitational potential energy at a point on the surface of the Earth? Shall we find W1? What is the equation for the gravitational potential energy? W equals minus G capital M simple M over R. W equals minus G capital M simple M over R. When you consider point 1 and point 2, what is common? G is common, capital M mass of the Earth is common, and they have given the gravitational potential energy. Okay, so they have now capital M means mass of the Earth is same for now when you keep the mass. Okay, let's say the mass is simple M initially, the simple M mass is here. Now the simple M mass is somewhere here, right? So then when you consider when the mass is at this location and when the mass is at this location, what is same for the potential energy? G is same for both of them. So when you find the gravitational potential energy of the simple M mass at here W1, and when you find the gravitational potential energy of the simple M mass at here W2, G capital M simple M constant. What is only varying? R. Remember, gravitational potential energy is proportional to 1 over R. That's it. So thereafter you can simplify it. Simplify it. Simplify it. We simplify it. Simplify it. Then gravitational potential energy at here is minus 16 over 3 proportional to 1 over distance measured from center to that W2 point 4R proportionally 1. Again, if you apply this proportionally for this point, W1, that's what you want to find. Not they ask, not W1 you want to find. They're asking something else. First of all, we'll find the gravitational potential energy of this mass at here. W1 proportional to 1 over R. When the mass is on the surface of the Earth, what is the R? Capital R. If you simplify this one, you are getting your W1 as how much? You are getting your W1 as how much? You are getting a W1 as how much? You are getting a W1 as how much? It's going to be, if you divide the equation proportionally 2 by proportionally 1, then your W1 going to be, if you simplify it, W1 going to be W1 over minus 16 H3 1 over R 1 4 R. It's 4. Anyhow, it's going to be, if I'm wrong, tell me, 1 over R 1 4 R. Simply W1 is, if we simplify it, your W1 going to be, if we simplify W1 going to be 16 into 4 means how much? 64. Minus 64 over 3. If I'm wrong, tell me. Minus 64 over 3 kilojoules. The question they are asking, when you are bringing the mass from here to here, when you are bringing the mass from surface of the Earth to that this point, when you are bringing the mass from surface of the Earth to this point, what is the minimum energy required? So we have done last week essay question also similar to this idea. Last week essay question also we had done similar to this idea, right? Therefore, you can't. You should get the answer correctly. To move the object from A to B. This is point A. This is point B. This is point. If you want to move the mass simply from A to B, the minimum energy means we told you. I told you that the minimum energy means what? The minimum energy means I told you that W2 minus W1. W2 minus W1. W2 is we know minus 16 over 3. W minus W1 is minus 64 over 3. Then plus 64 minus 16, 48 over 3. 48 over 3 kilojoules. How much? 48 over 3 means how much? 48 over 3 means how much? Here 116. 16 kilojoules. Story. 16 kilojoules story. Learn. Practice. Answer the second one. It's plus 16, not minus. Then this is also done. Then next they asking what? Then right. Right. Then anything easy? Any easy questions? 17. 17, just see. 17, I think when a bulb of volume 250 centimeter cube is manufactured, gas at 27 degrees Celsius temperature was contained in it under the pressure of 10 to the power minus 3 mercury millimeter. If the Boltzmann constant is this much, number of gas molecules approximately. Now they have given bulb volume, temperature, pressure. Bulb volume, temperature, pressure, Boltzmann constant. I want to find the number of molecules capital N. Question number 17. I want to find capital N. I want to find capital N. So then ideal gas equation, PV equals nRT. Ideal gas equation, PV equals nRT. PV equals nRT. Then how you are going to involve Boltzmann constant? Then PV equals number of moles means number of molecules over Avogadro capital N. R over this capital L here. This is what we call as Boltzmann constant, capital T. Normally Boltzmann constant we write as capital K. PV equals capital N. This is the Boltzmann constant, capital K. Temperature, absolute temperature, capital T. So you want to subject capital N. Subject capital N. Capital N going to be PV over KT. PV over KT. Capital N going to be PV over KT. PV over KT ni. PV over KT. P means pressure. 10 to the power minus 3. Look here. 10 to the power minus 3. Mercury millimeter. The problem is you want to convert mercury millimeter into pascals. How do you convert mercury millimeter into mercury meter? I have done the stories. I don't explain why. Mercury millimeter, if you want to convert mercury meter, multiply by minus 3. Then how do you convert mercury meter into pascals? If you want to convert mercury meter into pascals, what you should do is you should multiply by 13,600 rho g into 10. If you want to convert mercury meter into pascals, multiplied by density of the mercury, normally 13,600 into gravitational acceleration 10. Then the pressure is, this is pressure in terms of what? Pascals. And into, if you subject capital N, PV over KT. Volume is how much? 250 centimeter cube. 250 centimeter cube. How do you convert to meter cube? 250 centimeter cube, if you want to convert to meter cube. Into volume ni. If you subject in PV over KT ni, P is done. Volume is 250. I write here 250 centimeter cube. If you want to convert to meter cube, multiply by 10 to the power minus 6 over Boltzmann constant. That is how much? Boltzmann constant given us how much? Boltzmann constant given us how much? Boltzmann constant given us how much? That is given us 1.38. 1.38 into 10 to the power minus 23 into absolute temperature. Temperature 27,300 Kelvin. Now you want to simplify this. Please simplify this and tell me the answer. You guys tell me the answer now. Simplify this and tell me the answer bit later. Okay. Now someone tell me. Okay, later. Then later tell me. 7 discuss. How many finished so far? So far, how many questions we have completely discussed? So far, how many questions we have completely discussed? How many? Tell me how many we have completely discussed so far. How many we discussed completely? How many MCQs we have discussed completely so far? Uh, 23, including 70, 23. Question number 23. Ni? Then we started at 8, 5 or 8:10 something. Okay, right? What shall I do? We'll take a small break. Small, maybe I might take a small break, big break also. Time is then 9:50. 9:50. Normally 15 minutes. We did the break 15 minutes. Then you want to come at 10:05, maybe 10:10. 10:10 to 12 we'll discuss. Okay. Right, take a break and come. Take a break and come. Drink something, eat something and come. Stay focused. Yes. Right. Okay. Then the story. Then the story. Next story. Next story. Right. So then, okay. Give me 1 second. Right. Right. Okay. So we discussed question number 10. 10th one. When a train is at a certain distance away from the platform, it will sound its horn at a frequency of 500 hertz. When a person is running towards the train, when a person is running towards the train with a speed of 10 ms minus 1, the frequency and the wavelength of the horn sound heard by him respectively are. When a train is at a certain distance away from a platform, it will sound its horn at a frequency of 500 hertz. When a person is running towards the train with a speed of 10 ms minus 1, a frequency and the wavelength of the horn. I think here there's now Doppler effect. I think the train is at rest. Observer, the person is moving towards the train. Observer, the person is moving towards the train. Story. Question number. Question number 10. 10th one. When a train is at certain distance away from the platform, it will sound its horn at a frequency of 500 hertz. Natural frequency source. Natural frequency source is F naught is how much? That is 500 hertz. And our observer is moving towards the source. Observer is moving to the source with a speed of how much? V naught is how much? 10 ms minus 1. V naught is 10 ms minus 1. Then the speed of the sound in air, that is V. Speed of the sound in air is V. Then what is the equation? Apparent frequency heard by the observer. They are asking us to find the frequency and wavelength of the horn sound heard by himself. Apparent frequency. Apparent frequency equation. So we know that apparent frequency F dash means natural frequency. Normally source is at the denominator. Apparent frequency equals natural frequency simple F. Normally source is at the denominator. V minus Vs. Since the source is at rest, it's just V. Who's the denominator? Observer. When observer coming to the source, V plus V naught. V plus V naught. These stories I explained. Substitution. If I am wrong, tell me. Substitution. Natural frequency of the horn is 500 hertz. Then speed of sound in air. What is the speed of sound in air? The speed of sound in air is how much? That is 340. Speed of the observer is 10. 340 plus 10. 340 plus 10 over. This is going to be V. Speed of sound in air is 340. So then when you simplify this, 500 into 350 over 340. Just simplify this, tell me the answer. If we simplify this, what will be the answer? Can someone take calculator and tell me the answer? What is the answer? Someone tell me. Someone tell me the answer. 500 into 35 or 34. How much? Tell me the apparent frequency. Tell me the apparent frequency. Apparent frequency, tell me. Someone tell me the apparent frequency value. Just simplify this and tell me the value. 500 into 35 or 34. Any idea? Anyone? Can someone tell me? Uh, 514.7. 514.7. 514.7. That is approximately 515. 514.7. That is approximately 515. 514.7 hertz. That is approximately equal to 515. Then we found the apparent frequency, and also they are asking the apparent wavelength also. Apparent frequency of the sound wave. Okay, apparent wavelength V equals F lambda equation. I know the frequency. If I find the apparent wavelength, speed of sound is how much? 340. Someone tell me. 340 over apparent frequency is 514.7. Someone tell me what is the value of this 340 over 514.7. What is the answer? Tell me the simplify it and tell me the answer. Now they're asking us to find the apparent frequency F dash I found, and they're asking us to find the apparent wavelength lambda dash. Lambda dash. If you simplify this, what will be the answer? What should be the answer? What should be the answer? Hmm? Quickly. Anyone? Waiting for someone to give me the answer. 0.66. 0.66 something. 0.66. 0.66. Now, person is running towards the train. We didn't do any mistakes. Everything is correct. 0.66. But they have given 0.68. In this case, now if we consider 515, just rather than taking 514.7, just take it as 515. Tell me the answer. If you take 515, 340 or 515, what is the answer? 340 or 515, then what would be the answer? If you take 340 over 515, then what will be the answer? In that case, 340 over 515. Then answer. Other students, you also just take calculator and give a small support till you. Why like this? You also stay in the session, right? Need a support from you all, then only we can do this session effectively. If not, can't. Now 514.7, it's 0.66 means if you divide by 515, I think something else, it's okay. 0.66. Right. Then the answer is almost closer. The closer answer is 515 and 0.68. That's what we have to take. Other answers we can't take it. The answer going to be fourth one. Question number 10, the answer is fourth one. Question number 10, the answer is fourth one. 10th one discussed, 11 I discussed, 12 discussed, 13 discussed, and right. 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 Then next story. Uh, right. Okay. Uh, we'll go to The next story, 15. 15. Water vapor of mass capital M, pressure capital P with relative humidity 50%. Present inside a closed vessel of volume capital V, temperature T. Water vapor mass capital M, pressure P. Water vapor mass capital M, pressure capital P, relative humidity RH 50%, volume V, temperature T. Temperature T, volume V, RH 50%. Right. When another water vapor amount of mass to capital M. When another water vapor mass to capital M inserted to the vessel and its volume is decreased up to V over 3 by keeping the temperature constant, its new pressure would be, right. Then now you are adding another 2 capital M mass into this vessel. Already there is capital M mass of water vapor. When you add another 2 capital M water vapor mass to the container, the total water vapor mass in the container going to be 3 capital M. 3 capital M. And you are going to reduce the volume. Temperature constant. Temperature constant. Now mass is 3 capital M. Now the volume is V over 3. So the volume is V over 3. But we have no idea then what about the pressure? We have no idea. What about the gas pressure? Sorry, water pressure? We have no idea. Now let's say the now water pressure is, let's say, P dash something. P dash or P2 or whatever. P dash or P2 or whatever. Now the water pressure. Earlier water pressure was capital P. Now water pressure is, let's say, P dash. Now we want to assume in both the conditions, as per my understanding, this is not saturated. Now here the water vapor is unsaturated. We can apply gas laws. Now in this case also you want to assume that water vapor is not saturated, right? So in that case, these are unsaturated water vapor. We can apply gas laws. 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 Another water vapor amount mass to capital M inserted to vessel. Okay, by keeping the temperature constant. Its new pressure would be. Right. Okay. Then story. Then look here. Shall we find now pressure? If you apply ideal gas equations, then if you try to apply now pressure B dash, try to find now pressure B dash. Now pressure B dash in terms of P. Shall we find the now pressure? That's the best thing. If we find the now pressure, ideal gas equation PV equals nRT. Ideal gas equation PV equals nRT. Then temperature remains constant. Then PV means mass over molar mass. Capital number of moles means mass over molar mass. RT. Then molar mass constant, R constant, T constant. Then we know that, see here, here we know that pressure into the velocity proportional to the mass. So what you can do, if you apply this proportionally for first scenario, pressure is capital P, volume of the vessel, volume of the gas is capital V, into the mass of the water vapor is capital M. This is proportionally 1. If you apply this proportionally for the scenario number 2, pressure is, that's what I want to find, P dash, volume is V over 3, P dash, volume is V over 3, see, volume is V over 3. Volume is V over 3, proportional to, the mass is 3 capital M. Right? So then see, if I divide P dash by P, if I divide these two, then you are getting actually P dash, P dash over 3P equals 3. See, now the story. Now actually see what happened is, now I am getting P dash as 9P. What is the meaning of that? What is the meaning? What is the meaning? The meaning is, now when you consider before and after, now I considered now these two. Now this now initially such relative humidity RH is 50%. Initially RH is 50%. Initially RH 50%. Right. That means this water vapor is not saturated. Now when I was doing this question, I considered this water vapor yet unsaturated. Then only unsaturated water vapor we can apply ideal gas equations. That's what I have done. But if I have done, I am getting that P dash. Now, water pressure is how much? 9 times large than before. That means, as per my understanding, we want to understand this has saturated. And somebody will see when this value is wrong. Now is it possible? Now see, for the P pressure, when the pressure is now, R is what? We know, see, look at this idea. Look at this idea. RH means we know that the equation. RH equation we all know. RH means at that temperature capital T, current water vapor pressure over at that temperature capital T, saturated water vapor pressure into 100%. Right. Since both the scenarios, remember, they mentioned temperature remains constant. Remember, saturated water vapor pressure in both the scenarios same, P naught, P naught. Saturated water vapor pressure doesn't change, P naught, P naught. Why? Temperature constant means saturated water vapor pressure at that temperature same, P naught, P naught. Now see, currently pressure is P, current pressure is P, then on when the pressure is P, see, when the pressure is P, when the pressure of water vapor is P, RH is 50%. Now tell me what would happen if the pressure becomes double, RS becomes 100%. Even the pressure becomes double, your R is going to be 100%. But see, now I assume this as unsaturated. Then I am getting my P dash as 9P. So then remember, so we can't do this, but we can come to a conclusion of doing this. We can come to a conclusion. That means this is saturated. This has rate saturated. Saturated. Raise your hands. How many of you understand what I have done? Now we can't. If this is unsaturated, this is saturated. Then if this is unsaturated and if this is saturated, we can't apply gas laws for these two. So then my simplification is wrong. Right? We can't apply gas laws. We can apply gas laws. But by getting this value, we came to a conclusion that this is saturated, this is unsaturated. Up to now, everything is very clear answer. Up to now, everything is very clear answer. The way how I obtained this scenario is saturated, that idea is clear answer. Unsaturated, saturated. And now tell me, now see, I'm applying this equation for this scenario 1. Scenario 1, carefully listen. RH for scenario 1. If you apply for scenario 1, RH 50% must be equal to, the pressure is capital P. I try to find the saturated vapor pressure, P naught, at capital T temperature in terms of P. I try to find the saturated vapor pressure, P naught, in terms of capital T, capital P. In terms of capital T. So then we are getting, see, we are getting, we substitute P naught. Our P naught is how much? Our P naught is exactly 2P. 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 Now I'm not going to do anything. I'm not going to do anything. Very simple story. There was a water vapor sample in the vessel. Current, its pressure of the water vapor is P. Saturated water vapor pressure I defined as P naught. So then we noticed if this water vapor changes from this state to this state, we noticed as the water vapor reaches this state, water vapor undergoes saturation. Now this is saturated water vapor, right? This saturated water vapor. What I have done here is I considered this scenario and I found the saturated water vapor pressure in terms of P3 is 2P. Also, we know that since both the scenarios same temperature means both the scenarios saturated water vapor pressure is same P naught P naught. Now my question is, the question they're asking, the new pressure would be, tell me what is the pressure of the water vapor in this vessel. Put some replies. What should be the pressure of water vapor in that vessel? Put some replies. If you understood the story, you will tell me. If you understood, you will tell me. What would be the pressure of water vapor in the second vessel? Reply. Put some reply. Put some reply. Quickly. Very simple. We know this is saturated, that is unsaturated. Right? The water vapor pressure is P. Its saturated water vapor pressure P naught is 2P. Same temperature means both of them have same saturated water vapor pressure. Tell me, at least someone tell me, what is the water vapor pressure in this? Anyone? Any student? Hey man, anyone tell me? You should reply. Anyone? Bahishri, don't know? Minha? Pranali, what's up? Rushada? Anyone? Now I have given all the hints and all. I have given all the hints. I have given everything. Hands up. Shall I explain once again? Hands up. Shall I explain once again? Right. Once again. Think there is water vapor. There is water vapor. There is water vapor. Water vapor pressure is capital P. Right. At this temperature, saturated water vapor pressure is P naught. We know that we learn in theory classes, saturated water vapor pressure only depends on the temperature. Only think about pressure. Now there's a water vapor, its current pressure is P. At this temperature, this water vapor, saturated water vapor pressure is P naught. RH 50% means we know that still this water vapor is unsaturated. Then we realized as this water vapor comes from this state, when the water vapor reaches this state, we realized this water vapor is saturated. This water vapor saturated. This water vapor saturated. But since the temperature is same as T, saturated water pressure is same as P naught before. Even this scenario, both scenarios, saturated water pressure is same as P naught. Okay. But remember, this is unsaturated water vapor, saturated water vapor. Both the states have same saturated water vapor pressure. In this scenario, water vapor pressure is current water pressure is P. Its saturated water pressure is P naught. I wrote P naught as 2P. I found this P naught means 2P. What I want to ask is, what is the water vapor pressure in this scenario? What is the water vapor pressure in this scenario? Any reply? At least one student. At least one student. One student can reply. Why you don't know? It's 2P. It's 2P, right? It's 2P. Because I told you, if it is saturated, if it is saturated means RH 100%. If it is saturated means what? What is the meaning? It is whatever is saturated means this water pressure is equal to saturated water pressure P naught. P naught is 2P. It's 2P. Nice question. I don't know how many of you getting. If you have doubts, please ask. Then I will tell you. If not, right? Answer is third one. Nice question. Third one, right? So then 15 discussed in 16. Water mass 1 gram at 100 degrees Celsius temperature vaporizes under a constant pressure of this much. As a result, the water mass becomes 1671 centimeter cube of vapor at 100 degrees Celsius. It is a specific latent heat of vaporization. If the specific latent heat of vaporization is of the water is this much, change in internal energy during the above process. 16. A different question. It's a kind of different question. That story. Kind of different question. That story. That story. That story. Question number 15, 16. Is it 16? 16 one. Now you know that there is a water mass at 100 degrees Celsius. There is water mass, temperature 100 degrees Celsius. Okay. Vaporizes under a constant pressure. Pressure is constant. Pressure is constant, right? That pressure is given. This pressure is how much? Atmospheric pressure 1.013 into 10 to the power 5 Pascal. Right? Now vaporizes means you are supplying heat. You are supplying heat. You are supplying heat. This water absorbs that heat, and currently the temperature of the water is 100 degrees Celsius. You are supplying heat. You are supplying delta Q. When you supply delta Q, but this water absorbs that heat, and what will happen? This water undergoes phase change. Water undergoes phase change. Right? That's what they are telling. They are asking the question. The change of internal energy during the above process. So we all know the story. Remember, we all know the story. Internal energy means we can remember when they talk about internal energy, that means they are talking about thermodynamics. Delta Q, first law of thermodynamics. First law of thermodynamics, we all know that delta Q means delta U plus delta W. First law of thermodynamics, we know delta Q means delta U plus delta W. Delta Q means what? Amount of heat absorbed by the object or amount of heat released by the object. In this scenario, this water absorbs heat. Then only it can undergo a phase change. Then only it can vaporize. This water absorbs heat. How do you find the amount of heat absorbed by the water during a phase change? Delta Q means ml. Delta Q means ml. Mass is 1 gram. See the story. Yeah? Mass is what? Delta Q means this water absorbs heat. Therefore, delta Q is plus. Delta Q is plus. Delta Q is ml. Mass of the water is how much? 1 grams. If you convert to kilograms, 1 into 10 to the power minus 3. It means what? Specific latent heat of vaporization. 2.256 into the power 6. 2.256. 2.256 into 10 to the power 6. Must be equal to delta U. Must be equal to delta U. Must be equal to delta U plus delta W. We know that we learned in thermodynamics, delta W means the work done by the gas or work done on the gas. When the gas expands, we know that when the gas undergoes expansion, when the gas expands, we know work is done by the gas. Therefore, delta W is plus. In this scenario, they are telling initially water mass was 1 centimeter cube. Then they told that water becomes 1671 centimeter cube vapor. Volume has increased. Volume increased. Therefore, this water undergoes expansion. Therefore, delta W is plus. Work is done by the gas. When the water converts from water to vapor, volume increases. Therefore, it's an expansion. So therefore, work is done by the gas. Pressure work done means what? We learn this equation. Delta W means P delta V. P delta V equation. The pressure is atmosphere pressure constant. Atmosphere pressure 1 point. Nice questions. If you practice this, exam questions are not difficult. But doing this need your support. If not difficult. Right? If you all are supporting me, we can do something big. But right? P into delta V. Change in volume. Delta V means change in volume. Delta V means change in volume. 1.013 into 10 to the power 5. Delta V means change in volume. Change in volume means we know that Final volume is 1600 and somewhat. Final volume is 1671 minus 1. 71 minus 1 centimeter cube. How do you count meter cube? Centimeter cube. How do you count meter cube? Centimeter cube. How do you count meter cube? Multiply by 10 to the power minus 6. So then, when you simplify, you get the answer. Hands up. This story is clear. Hands up. Nice question. A different question. They can ask an MCQ like this. Hands up. This story is clear. Hands up. This story is clear. Hands up. Then I need your support to simplify this. If I simplify it, I take lots of time. So therefore, if you can simplify and tell me it's better. If you can simplify, tell me it's better. I know that only one student is doing all simplification. I don't know why. If that student also not simplifying, I don't know how we can continue this class. Need your support. If not difficult, right? The support, then we can do the class nicely. Simplify it and tell me the answer because we don't have time. Time is passing. 16 does the idea. And then someone tell me the answer. The previous simplification was 17, I think. 17 or something. 17 is 17 also. I need your simplification. I want you to tell me the answer. 17. 18 done. 19. 19. 19 story. 19. 19. Air resistance against the motion of a vehicle on a straight road. Now, don't worry. Now we are doing these questions for a practice. You don't bother with your marks, and what you do, just practice these question papers and go to the exam. Because if you practice these papers and go to the exam, then your exam paper is very simple. Right? Don't bother with your marks. Just practice and properly write the paper. And just discussion is very important. Air resistance against motion of a vehicle on a straight road with velocity v is given by the equation F equals 4v square. When the velocity is ms minus 1, the value F, when the value F is obtained in Newton. Power required to maintain the uniform velocity on a vehicle in the horizontal road at 30 ms minus 1 is. Okay. Now, simple story. Now, there's a vehicle. There's a vehicle. Now, when this vehicle moves forward direction, the air resistance force opposing the motion, the air resistance force acting on the vehicle can be found by the air resistance force. Let's say that is if the air resistance force can be found by F equals 4v square. The air resistance force acting on the vehicle is 4v square. Right? The power required to maintain the uniform velocity on a vehicle in the horizontal road at 30 ms minus 1. They are telling this vehicle is moving in a constant velocity 30 ms minus 1. This vehicle moves under constant velocity 30 ms minus 1. Then we know that this vehicle moves under constant velocity means resultant force acting on the vehicle must be 0. Then there must be a, now this is the resistance force. In order to move the vehicle forward direction, engine produces a force. Engine produces a force on the vehicle forward direction. So we know the requirement. If the vehicle moves under constant velocity, this Fe must be equal to this resistive force. And anyone can tell that the force produced by the engine, the force produced by the engine going to be equal to 4v squared. Fe must be equal to F. That means 4v squared. What is the V? 4 into velocity is 30 squared. 30 squared. Right? This is the force produced by the engine. They are asking the corresponding power produced by the engine. They are asking the power produced by the engine. They are asking the power produced by the engine. Then power means we all know the power means what? I told you in the equation, remember power means what? Force into velocity. Force into velocity. Then the force produced by the engine is this much. Velocity is again 30. Force is 4 into 30 squared. Velocity is again 30. Simplify it. What is the answer? Simplify it. 3 into 3, 9. 9 into 3 means how much? 27. 27 into 4 means how much? 8. 108. 108. Then row 3. If I am wrong, tell me. 108 kilowatt something. The answer is second one. Answer is second one. How many questions discussed so far? Did you reach 30? Did you reach 30? Answer is second one. How many discussed so far? Then 16, someone is telling answer is 2086.8. What is the answer then? 2086.8 means 2086. What simplification? 2086.8 means answer is third one. 16 answer is third one. Right? Am I correct? 2086 point something means 2086 point something means 2087. Answer is third one. Right? How many discuss so far? We discussed time is 10:50. Right? Have we done 30? 27. 3 to go for 30. 3 to go for 30. We start at 8 o'clock. Time is now we took a 20-minute break. Then now time is 10:50. 10:50 means 10:45. 10:45 we started at 8 o'clock. Then we have do this discussion for continuously 2 hour and 50 minutes. 2 hour and 50 minutes. We have done 27. It's really nice speed. It's a good speed. It's a good speed. It's a good speed. Right. Okay. Now question number 24. We'll try to solve this 24. 24. Which one of the following statement regarding the optical instruments is not true? Optical instruments is not true. Option 1, final image formed in a simple microscope is virtual. That's correct. When you get a simple microscope, the final image formed by simple microscope is virtual. That's correct. The final image formed in a compound microscope is inverted. That's also correct. In a compound microscope, final image is inverted. That's also correct. The image formed by the objective in a compound microscope is virtual. When you consider microscopes, raise your hands. How many we say? Statement 3 is correct. The image formed by the objective lens in a compound microscope is virtual answer. Raise your hands. Statement 3 is wrong answer. Because we know that when you consider objective lens, I'm not drawing. When you consider objective lens, object is in front of the objective lens. Right? Remember, objective lens creates a real image. If you can remember, if there are two lenses, compound microscope, remember there are two lenses. Compound microscopes, remember there are two lenses. One is objective lens, other one is eyepiece. You keep the object in front of the objective lens. So this for the objective lens, object is the object. It creates a kind of real image. So therefore statement 3 is wrong. Statement 3 is wrong. So then question number 24, answer is 3. 24 answer is 3. Next story. 24 answer is 3. We discussed in 25 discussed 27, right? 30. 30. S1 and S2 are two stationary sources that emit sound waves. S1 and S2 are two stationary sources that emit sound waves of frequency f0. As shown in the diagram, man walks at a speed v towards S1 along the line joining S1 and S2. Velocity of sound in air v, beat frequency heard by the man is. The beat frequency heard by the man is. The beat frequency heard by the man is. Speed of the capital V, velocity of the sound is capital V. Man's speed is V. Simple V. Moving towards S1. Look at this idea. This idea. That question. Question number 30. Question number 30, I think. Question number 30. Question number 30. Question number 30. Story. There are two sources. S1, S2. S1, source S1, And this is our man. This is our source S2. Source S2. So they are natural frequencies, if not F naught. The natural frequencies, if not F naught. But you know that this observer, source is these two, observer is moving towards this one. Speed of the observer is simple v, simple v. Then we know that just forget about this S2 source. S1 source produces a sound of frequency F naught as it reaches the observer. Apparent frequency of that apparent frequency heard by the observer. The apparent frequency heard by the observer is what? Let's see. The apparent frequency heard by the observer is what? I say if not F dash. Sound speed is capital V. Sound speed is capital V. Right? One story. This is simple V, capital V. Don't write wrongly. Then see now. Okay, I take this story. Then we know that observer is moving towards the source. Then the apparent frequency F dash means we know the equation. What is F dash? F dash means we all know that natural frequency of the sound source is F naught. Source is moving. Sorry, observer is moving. Observer is moving. That means at the denominator, source is at rest. Source is not moving. That means source is at rest. That means capital V. Since the observer is moving towards the source, apparent frequency is larger than the actual frequency. Therefore, in order to get the large, since the observer moving towards the source, apparent frequency F dash is larger than F naught. So therefore, capital V plus simple V. This is one way. Okay. Next story is this one, S2. S2. Person is moving, this observer is moving away from S2. Right? Observer is moving away from S2. The apparent frequency heard by the observer of the sound is F double dash. Double dash. Then the equation. Just consider these two. Then the apparent frequency F double dash going to be natural frequency of the source S2 is F naught. F naught. Source is stationary, therefore denominator is capital V only. Capital V only. Numerator, observer is moving away from the source S2. Therefore, capital V minus simple V. They are asking the beat frequency, but anyone, if I ask you which one is larger, F dash is larger or F double dash larger? V plus V, V minus V, remaining same. Anyone can tell it. That's F dash is larger, V plus V, V minus V. F dash is larger than F double dash. You want to find the beat frequency. This person is hearing two frequencies, F dash, F double dash, larger F dash minus smaller F double dash going to be beat frequency. F dash minus F double dash going to be beat frequency. Simple. Nice story. Nice story. Beat frequency means FB means what? F dash minus F double dash. Simplified. Nice questions are there. Nice questions are there. Nice questions are there. Nice questions. F dash. Then if you simplify this, okay, just substitute here. Substitute if you subtract, if you simplify it, you will get that what? This we cancel out. It seems like you are getting. I feel like you are getting. Just 2 if not. I think something 2 if not. Any answer like this? Are the answer 2 if not? Why no? No. This is. If you add them, the beat frequency heard by the man is velocity of the sound is in air. The beat frequency heard by the man is. This is correct. No issue. This is correct. On subtract. Man is moving away from the observer. If not, V means okay, right. Somehow you should get. I think VV cancel out now. This is capital V. This is capital V, speed of the sound, right? So, but they have taken like this. Any answer to V F not OV? To V F not OV? I think we have to take the answer as third one, but you want to understand, see, when you subtract this, simple V means speed of the observer. Capital V means speed of sound. Now, in this case, if you add them, oh, okay, my bad. Okay, right. But subtract me. My bad, okay. Okay, now I will do it properly. Then, okay. If not, capital V, right? Capital V plus simple V minus, if not capital V minus simple V. Common factors, if not over capital V common factor, capital V plus simple V, this one, minus capital V plus simple V. All right, okay. Got it. Then simple V plus simple V, 2 simple V. Then the answer is 2 simple V, if not O capital V. Nice question. Answer. The story is clear answer. Beat frequencies. This one is clear answer. This one is clear answer. This story is clear answer. This story is clear. Right, you are tired. Tired only, but what to do? How to do ni? How to do the stories? 31. Figure shows an idealized bird. 31. Tired only, but what to do? 31. Figure shows an idealized bird considered as a point source. If you move twice the distance from the bird, the sound intensity will drop by. If you move twice the distance from the bird. Now let's say earlier, this is the bird is your sound source. Bird is your sound source. Initially, you are at a distance of simple r. If you move twice the distance from the bird, now you move twice the distance. Earlier, you were a simple r distance from the bird. If you move twice the distance, now the distance to simple r. Then I told you, if you can remember, intensity means, I told you that intensity means what? We can remember intensity means what? Power over area. Intensity means, I told you that power over area. Power over area means 4 pi r squared. And I told you that intensity is proportional to 1 over r squared. Right? Intensity is proportional to 1 over r squared. Intensity is proportional to 1 over r squared. Right? Okay. They have given, you may assume the intensity inversely proportional to square of the distance from the source. But data is missing. Figure shows an idealized bird considered as a point source. If you move twice the distance from the bird, sound intensity will drop by. Sound intensity will drop by. They have given in the answers intensity level. I think this question should be corrected as sound intensity level will drop by. Then that means you want to find delta B, delta beta. This question, I think we should be corrected as sound intensity level will drop by. Then we can do something. Right, okay. Let's say when you are at R distance, intensity is I1. When you are at 2R distance, intensity is I2. Now I is proportional to 1 over R square. Then I1 is proportional to what? I1 is proportional to 1 over R squared. I2 is proportional to 1 over 2R squared means 4R squared. Then we know I1 to I2 ratio. I1 to I2 ratio is how much? I1 to I2 ratio is how much? I1 to I2 means how much? Just 4. Just 4. Just 4. Then we know they are asking, if you move from here to here, they are asking us to find the change in intensity level. This question should be credited as change in intensity level. Delta beta. Delta beta means we all know that 10 log I2 over I1. I2 over I1. Story. 10 log I2 over I1 is right? I2 over I1 means, mm, right? I2 over I1. I2 over I1, I1 over I2, okay, R squared, okay, 4R squared. I1 over I2 means 4 ni. I2 over I1. Okay, see, I1 is larger ni. I1 is larger, I2 is smaller. Right now, very clear. Intensity I1 is larger, I2 is smaller. Right, I1 over I2 is 4 over 1. Now we'll do like this. Delta beta means larger intensity level minus smaller intensity level must be equal to 10 log. I2 means larger intensity. I1 means smaller intensity. If I write this as IA IB, then you don't confuse. IA IB. Then IA to IB ratio. IA to IB ratio. Large intensity over small intensity ratio is 4:1. Remember here I2 means remember larger. Remember I2 means larger intensity level. Remember I1, sorry, I2 means large intensity. I1 means smaller intensity. 10 log large intensity over small intensity means IA over IB, that's 4. Remember 10 into log 10, 4 means 0.6, 6 decibels. 6 decibels answer. 6 decibels answer. How many finished so far? 30? 6 decibels. Normally 10 MCQs 1 hour. That is the way. 30 MCQs 3 hours. Hands up. How many finished? 30 finished. 30 finished. Oh god. Hands up, tired, hands up. Genuinely tired. Yes, very tired. I'm also feeling very tired, but 20 to go, ne? 20 to go, 11 o'clock. 11 o'clock, and we have one essay question and 4 structured also. Yes. Right. Okay. Right. Okay. Right. Okay. Then Saturday, Friday, today. Okay. So far, every question we have discussed 30 good questions. These are not simple questions, nice questions. All these 30 questions are crystal clear answer. All these questions are crystal clear answer. It is very clear. Everything is very clear. 20 to go. The next week essay paper. So now what I understood is now week wise doing full paper. I don't know. Now we are doing 50 MCQ next day, a full essay paper, right? So then I don't know. Tell me your comments now. If you are doing full paper, the discussion is not easy as you think. Just think, see, even now we have discussed 33 hours. We didn't talk. We didn't talk anything. We are discussing. In that case, also we realized that how much time we are taking. Therefore, if you are discussing full paper means I need at least 12, 13 hours for discussion, right? I don't know. You guys decide and tell me what you prefer. Okay, now 10, 20 to go. 20 go tomorrow morning. Tomorrow morning. Tomorrow morning. Uh, Normally I do Friday 8 to 12. If you are tired and if you can't finish it, Saturday morning. Okay. Now Saturday morning. Sunday. Okay. What shall I do now? We have 20 and we have that essay paper also. We have one essay. Structured for essays, we can quickly finish it. Uh, what shall we do now? Then what can I do? Saturday, tomorrow. Tomorrow, Sunday. 9 to 4. Sunday evening we have classes. 25 people have theory class and passive discussions. Saturday also evening time we can't do. Tuesday also we can't do. Tuesday theory ni. Then Wednesday again Thursday next paper. Ah, yes. Mm, right. So what will I do now? Tomorrow, now 20 questions to go. Ni. If I discuss 20, finish. Ni. Tomorrow, 7 a.m. to 8 a.m. Okay. 7 a.m. to 8 a.m. We'll plan to do 10 MCQs. We'll plan. Maybe not possible. 7 to 8, 10 MCQs. Again, Saturday, because Saturday, 12 to 1. 12 to 1, 10 MCQs. And we'll plan, then we'll finish it. Okay. We'll plan in that way and we'll finish it. So, session is effective, hands up. Session is effective. Before writing essay paper, we will finish everything. We want to finish everything. We will finish everything before writing essay paper. Need your support. Need your support. Then only we can do this properly. I know if we do this properly for these 3 months, definitely your marks will improve. But need your support. If not difficult, support me. Then we can go for a good way. Okay, then today we'll stop the session. Then before this Monday morning also can, because I'm not going to office also. We'll see. We'll see. Somehow before Monday we'll finish this entire story. Again, when it comes to next week, then we'll do a new essay paper. Don't worry, we can do. We have time. Monday I have time. Okay. Monday morning I have time because I'm not going office on Monday. Right. We'll stop for today and effectively work. Ready? Should work. Okay. Then we'll stop the class for today.